So I wanted to do a brief video of the vision challenges. This is an example workflow I was trying to work out. This is like my living room, or part of my living room. Anyway, this is 24 inches, 36, and then 48 inches away from the camera. This is like a central line right here. And then this box is moved to the right, I believe the same dimension as its width. Probably doesn't look right, but yeah, I've got these written down somewhere. But I was trying to figure out, so the camera, when you look at this thing physically, like it's up here, so the box is drawn like that. However, the distance sensors are below. So one of the problems I have to figure out is, like, if a camera sees something in frame, you know, like this, what do you do to point a beam at it? Because there's the trigonometry parallax or whatever issue, or is it perspective? I don't know, it's like where, you know, an angle changes the distance left and right however farther you are, the farther away you are. So there's that, and then the offset angle pointing aspect as well I mentioned. But that's only part of the problem. The other thing is the vision aspect. Like, so this is like a sample picture that was taken. I think this is zoomed in right now. This is your frame, and looking at this picture, like, as humans, you're like, oh, this is the floor. And there's like three things here. There's that frame over there, which is far away. It's behind this thing. But the OpenCV part, you have to like clean it up and find stuff. And the approach I'm taking right now, which seems to work, although it's still like a manual process, is to use histograms. Like, one-dimensional histogram will tell you like the light distribution in an image. So the x-axis, this is a 2D histogram, I'm just pointing at something, but I don't think I have a picture of it, but yeah, 1D histogram, it's like 0 to 255 or something left to right, and then I think it's light to dark. Well, I could probably find it. Where is it? Oh, yeah. Yeah, there's a 0 to 255. Let's try to come inside here. So, yeah, the light tells you the V for HSV, and then the H and S values come from the 2D histogram, which is pretty cool. So yeah, this is the problem, which I have to figure out, like come up with an algorithm to determine like that I got everything. So you'll get like a patch like this, and you can roughly estimate. S is, I believe, the x-axis, so you know it's gonna be like the absolute bounds. It's like 10 to like 120. There's a little more actually down there. So there's some over here too. And then the h-axis, the y-axis here, you know, it's like 50 to 110. But when you apply that, it's like terrible. So you have to like reduce it, find the bounds. You also have to like change the V value for the lighting. So I mean, when I got this result here, like, that's pretty good, but that's because I like know already that these are like the only main objects to be concerned about. The algorithm doesn't know that, And I think I'm gonna cheat partly by using a probe. There's a lidar. It's an LED lidar, but on the sensor bed here that has the ultrasonic sensor and the lidar. So I'll do like a panning scan, and that'll tell me like what's in the way right away, immediately, and then I can verify it with the OpenCV. I also have to like profile the floor so I know where the horizon is. But yeah, and then writing code that translates all the way down to Arduino stack or layer is a process, because I'm using Python like CLI call to pass the variables down to Arduino, and then from Python I2C aspect I'm sending commands down to Arduino by I2C. I'm not saying it's like a clean way to do it, but it was just what I thought about how to do it at the time. Originally I was going to run everything off of Python, but then I had problems with the servos, and then I thought I was going to have to use Arduino as well to interface with the ADC, but it looks like you can just read it directly through serial or something. So anyway, ideally you just have one board, maybe like a single language if possible, but I don't know. So that's what I'm trying to figure out right now. And then once we have these bounding things, the simple approach is to just treat it as a cube, whatever dimension this is, and then you store those 3D points, and then in the Python's like running memory, tied with the IMU values, as you move you can estimate like how far the coordinates shifted, and then you can tell like where you are in the world. It won't be blind, but yeah, it's tough though. I haven't even interfaced with the IMU yet. My plan for December is to get this entire project done. I mean, the whole thing's ugly, but I'll learn a lot in the process. Then I'll finally have interface with an IMU, and I've actually like figured out how OpenCV works to some extent. So yeah, I'm gonna try and get that worked out.